Guided exercise number 3 says estimate the area under the curve f of x equals 1 over x squared between x equals 1 and x equals 4 using right endpoints and 5 rectangles of equal width. Use the graph of f to explain whether your estimate is an overestimate or an underestimate. So this time my delta x is going to be 4 minus 1 because of my x equals 1 and x equals 4. And then all over 5. So my delta x is going to be 3/5. Originally on my paper, I subtracted wrong because it's easy to do because nobody's perfect. And when I wrote out my subintervals, well, let's go ahead and write out our subintervals and I'll tell you how I knew I made a mistake. So we're supposed to have 5 subintervals. And the first one is supposed to start at 1. And then, by the way, that's 5/5. And you're supposed to get that subinterval's right endpoint by adding delta x to the 1. So 1 plus 3/5 is 8/5. And then the next subinterval should start at 8/5. And then add another 3/5, so you get 11/5. The next one should start at 11/5, add another 3/5, and go up to 14/5. Next one starts at 14/5, add 3/5, and you get 17/5. And then the very last one, which I barely maybe have enough room for, starts at 17/5, and you add 3/5, and you get 20/5. And 20 over 5 is the same thing as 4. We were supposed to start at 1 and end at 4 and have 5 subintervals. Double check that you have 5 subintervals. 1, 2, 3, 4, 5. Yes. We started at 1 and we ended at 4. When I made a mistake subtracting on my paper, I could tell that I had done it because when I got to this point at the very end, when I had 5 subintervals, I didn't end at 4. I ended at something else. And so I realized that I needed to go back and check my subtraction to get my delta x. So those are our subintervals. Now, it's really hard to mark these on your graph. You're going to have to just eyeball it a little bit. So 3/5 more than 1 is maybe about here. And then I'm supposed to be at 11/5. Let me cheat and scoot that to the left a little bit. And then a little bit, so here's 1, here's 8/5, 11/5 is approximately here, 14/5 is just under 3, and then 17/5 is about here, and 4 is there. And so we've got 1, 2, 3, 4, 5 subintervals marked from x equals 1 to x equals 4. So on this one, we're supposed to use right endpoints. So on my first subinterval from 1 to 8/5, I'm supposed to use the 8/5. And so here's the 8/5. I'm going to use it to get the height of my rectangle that goes with that first subinterval. Second subinterval, I'm supposed to use 11/5. Here's my 11/5. So I find f of 11/5 and use that for the height of the second rectangle. And then I'll do the rest of them in blue. So 14/5, 17/5, and then 20/5. So 14/5 is here. Go up to that point with height f of 14/5. Use that for the height of this rectangle. And then the rectangles get really short and really hard to see, but approximately that's what they work out to be. Okay, so the area under the curve is approximately equal to f of 8/5 times delta x plus f of 11/5 times delta x, and I'm actually putting in the delta x as 3/5, but you could put it in as a delta x and then change it in the next step, plus f of 14/5 times delta x, plus f of 17/5 times delta x, plus f of 4, go ahead and use a 4 there instead of 20/5, times delta x. And then to really be done with this problem, well, we still have to do the over-under, but we also need to actually plug the values into the function. So note, 1 over x squared is the same thing as 1 over x all squared. And so these fractions that I'm supposed to be plugging in, I can do the reciprocal and square to plug in quickly. So what I have here for the area estimate will be 5/8 squared times 3/5. That's 1 over x and then quantity squared, plus 5/11 squared times 3/5, plus 5/14 squared times 3/5, plus 5/17 squared times 3/5, plus, and then I'll go ahead and do this one as 1/4 squared times 3/5. So that's our area estimate. And the last part of the question is it over or under? Based off of the picture that we drew, it's definitely an underestimate. It's an underestimate since the rectangles miss some of the area under the curve. From x equals 1 to x equals 4. So this estimate that we got here, whatever it works out to be, has to be an underestimate based off of the picture.